Today's video deals with reaction mechanisms. Now think about a chemical equation. When we balance a chemical equation, we see the reactants and we see the products. But what we don't see is a lot of the stuff that happens in between. It's almost like a chemical, when you see a chemical equation, you aren't seeing the whole thing. You aren't seeing the exact steps that are taken for a reaction to happen. That's what a reaction mechanism is. In a reaction mechanism, it's a way of splitting up a chemical reaction into its individual, what are called elementary steps. And those elementary steps are again exactly what's happening in that chemical reaction. So most chemical reactions can be split up into 2, 3, 4, 5, 6, who knows how many different what are called elementary steps. For example, when the ozone layer, the way that the ozone layer protects us from the earth, from the UV rays from the sun, protects the earth from the UV rays, is the chemical equation is 2 O3s become 3 O2s. However, that doesn't really tell us what's exactly happening. What's really happening is one ozone molecule gets hit by a UV ray and then it breaks a bond between one of the oxygens and another, and you end up with O2 and then an oxygen atom. And then that oxygen atom can then come down here in step 2 and react with ozone again and make 2 more oxygens. Okay, now what you can see here is that just like with net ionic equations, notice that we formed oxygen, an oxygen atom, and then we used it again. So in the overall equation, that does end up canceling out. Again, like a net ionic equation, when you have things that are the same on both sides, even if they're in different steps, they do cancel each other out. Okay, and now if we just add up the reactants and add up the products, we have 2 O3s as reactants, and you have 3 O2s as products. But see how when you just look at this, you don't really see what's exactly happening. But when you look at the reaction mechanism, you go, oh, that's exactly what's happening in that reaction. The ozone molecule breaks apart into O2 and O, and then that O atom reacts with another ozone molecule and makes oxygen O2. Okay? Now, when something is produced in one step and then used again in a later step, and it doesn't have to be the very next step, it could be step 3 or step 4. So let's say the oxygen atom was produced here, but then wasn't used again till step 3 or 4. That's fine. Okay, when that happens, that is what's called an intermediate. Okay, you've made something in between that isn't going to show up in the overall equation because you make it and then you end up using it again. And so again, in the overall equation, you don't see that O atom anywhere. Okay, that is what's called an intermediate. Now, these reaction mechanisms can contain 2 different things. They can contain intermediates, which we just talked about. They also can contain catalysts. Okay, again, intermediates are particles that are formed in one step. So intermediates are formed in one elementary step and then used up in a subsequent, a later elementary step. Okay, now how is that different from a catalyst? A catalyst is something that you have to start with. It has to be in step 1 and it has to be a reactant. And then again, it has to show up again later as a product. And again, a catalyst will cancel out and you don't see it in the overall equation. Okay, so so a catalyst is present at the beginning of a reaction and again present in the exact same form at the end of the reaction or simply just a later step. Usually it is the end of the reaction though. That is a catalyst. Okay, for example, the mechanism for the catalyzed decomposition of hydrogen peroxide, this is the elephant toothpaste demonstration, produces water and oxygen as shown below. The overall reaction is also shown below the 2 elementary steps. Again, how did we get there? We combined the 2 elementary steps. We canceled out the catalysts and the intermediates. Okay, notice that, again, you start with I minus here and you end with I minus here. Okay, so it's present at the beginning of the reaction and at the end of the reaction and is therefore considered a catalyst. Okay, in this case also notice IO minus is formed and then used again. that also doesn't make it a catalyst. That makes it, remember, an intermediate. So again, all of those things end up canceling. And so you're left with those 2 hydrogen peroxides. And then here's your 2 waters. And then you've got your oxygen. Okay. Now, in terms of a rate law, remember when we write rate laws, rate equals K times the concentration of X times Y. Think about catalysts and intermediates, okay? Because they're not in the overall equation, they typically, but they can, they typically do not appear in rate law equations, okay? But they can if they, again, you'll see some examples where that will happen later on, okay? Intermediates, on the other hand, are almost never found in rate law equations. So catalysts, again, both of them usually aren't found in rate law equations, but catalysts, if one of them is going to be in there, catalysts will be in there more often than intermediates. In very, very rare cases, which we'll see, intermediates are, again, almost never found in rate law equations. Okay, example 1, identify the catalyst and the intermediate in the mechanism below, then write the overall equation. So we're starting with some V2O5, we're forming some V2O5, therefore V2O5 is a catalyst, and then we're forming V2O4, and then we're using up that V2O4, which means that V2O4 is an intermediate. And now, if you notice, just overall, what do you have? You have SO2 reacting with half of an O2, making SO3. Notice that the vanadium compounds, you don't see it all in that whole equation. What's the vanadium? What's that V2O5 there for? Remember, what do catalysts do? They speed up the reaction. Again, we'll talk, we're not done with catalysts, but that's what this, by doing it this way, it makes the reaction go faster. Okay, example 2, identify the catalyst intermediate in the mechanism below, then write the overall equation. So let's see, we started with some A and we ended with some A. So A is the catalyst. Okay, and those are going to cancel out. Let's see, we produced some C, and then in step 3, we used it again. So C, I'm going to leave some space because there might be more intermediates. C is an intermediate. And then let's see, D we made and then we used again. So D is also an intermediate. Let's see, and then F was made and then again used again. So F is also an intermediate. So overall, what do we have left? Not much. The overall equation, which again, if you think about it, this reaction mechanism and isn't even close to the overall equation. The overall equation would just be B plus E makes H and G. And see how when you write an overall chemical equation, see how much you're missing? You're missing so much. All you see is this is what I started with and this is what I ended with. Where a reaction mechanism really shows you the whole thing. Step 1, this happens. Step 2, this happens, etc. All right, example 3, and then that will be our last one. Whoa, that'll be the last one here for this video. So example 3, identify the catalyst intermediate to the following reaction mechanism, and then write the overall equation. So you can kind of see they're all somewhat similar. So let's see, N2, I don't see N2 anywhere else canceling out. Okay, no big deal. So it's staying in, it's not going anywhere. Okay, L though is a reactant, and then at the very end it's a product. So L is definitely the catalyst, and it's going to cancel out. Let's see, and then I just go to NL. So NL, yep, is here. It gets produced and then it's made again. So NL and maybe others. Intermediate. So it's going to cancel. And then let's see, we've got N and N. So again, product and then reactant. So N is an intermediate. Sometimes students mess up and think that A is an intermediate, but they're both reactants. See how they're both reactants? Or even Na2 and Na2, They're both products, so no, they do not cancel. In order to cancel, they have to be on opposite sides of the equation. Okay, like the N and the N are on opposite sides, reactants and products. Okay, and so the only intermediates, yes, are NL and N. Nothing else cancels. So overall, we're going to have N2 plus 4 A's, right? Because you've got the 2 A's plus the 2 A's, making, and then we're going to have 2 Na2s. Now, and remember, guys, that one of the things you can do to make sure you have this overall equation correctly, it better be balanced. If it's not, then you messed up somewhere. There's 2 nitrogens, 4 A's, 2 times 2, 4 A's. That is a balanced equation, so that is correct. So just a good idea when you get done, when you're combining all the steps in a reaction mechanism to make the overall equation, just know that it does absolutely have to be balanced. Obviously, with like this one up here, you're not going to balance that because it's not. But even with this fake element A and L and all that, it still is a balanced equation.